Okay, so my project is a stretched out um, object that I applied a brick material to. I got this brick material alongside many of the objects and actors you see in my project. I got them from a free package called the Stylized Egypt package. Did I pass? I think I passed it. There, the Stylized Egypt package, which contains meshes, textures, materials, and even its own maps that you can put into your own project, which is pretty cool. And I also use SCK Casual, which has meshes to use for characters and even pre-made characters. And I can show. I even replaced the mesh for the player-controlled character using one of their pre-made characters. So if I open it up, you see at the top it says climb to the top of the statue. That plays from a string blueprint that I have. But you can see the player control character has this mesh. And yeah. So for the principles of OOP, and also I have like you hear the footstep sound effect. I have that and have a celebration sound effect, which I'll showcase later. This isn't in my project yet. I haven't implemented it. But for the principles of OOP, we can start with polymorphism. So I think I'll turn to my third person character. So the I have the boolean moving. Now before we even reached the moving boolean, we check this and check to see if this is true. So all these conditions are true. Before we even reach that point, it's first going to come from input action move, and it's also going to come from add movement input, and then that's also going to come from add movement input, and that's going to go to the branch to check to see if these inputs are true. So based off of this alone, you can already understand that moving in this case doesn't mean you're moving away from something. It doesn't mean you're moving towards some place. It doesn't mean you're moving an object. It means we're, as the player pawn, we're moving um, our location. So we are, as the player, are moving from one place to another. And by we as the player, I mean the pawn. The pawn is moving from one place to another. That's what the moving boolean means in this context, based off of the fact that we have these inputs. And then the output is going to be creating a footstep sound. So you can kind of presume what moving means in this context. It means if the player is moving or using its controls to move around. That's what moving means. And I don't directly say that, but it is heavily implied through the inputs, which is polymorphism. And then we have, I guess, encapsulation, um, which I can show with, I guess, my ornament. So with any actor I have in my project, I keep all of everything the class needs inside of its own class. So for this, I don't have like a boolean that calls from another class, and I don't have like a variable that calls from another class, or it doesn't need any information from another class. All of its information for its own class is in its own class. I made sure I kept it like that just so it doesn't get overly complicated, and just to show off encapsulation within my project as well. So, moving on, we can move on to abstraction. So, for abstraction, I have speed. Now, speed really does mean it's like the change of the vectors, the x, y, and z vectors, um, per second, right? If I break this link, you can see here the change. This is the x, y, and z vectors um, right here being multiplied by the difference between the player pawn location and the ornament actor location. Um, that's being multiplied by the speed here to then get added to the actor's location, the ornament actor's location, and set that new location to that spot, right? So with um, abstraction, it just simplifies it. Instead of having to go into the code and change these values, you simply have to go to the variable itself, and then you see speed, you change the value, and that's how fast the how many units the actor is going to be traveling over time, right? Just to make it simpler for me and anyone else who's trying to make changes to my project. And for inheritance, the last principle of OOP, I have a parent class and a child class. So the parent is this hoop, and this is the child hoop. Now, if I touch this parent hoop, it's going to create this smoke. And we know that the child is going to inherit anything the parent has. So this, when I touch this hoop, it's going to also create smoke. However, it also destroys itself, unlike the parent. And that is because if I go to content blueprint objects, so this coin hoop itself, it has a on, whoops, um, am I not sure why it's opening. There we go. Okay, so when the player pawn overlaps with this actor, it's going to spawn the smoke effect, the smoke particles, and it's going to get the actor transformed so it knows where to spawn the smoke. So because it's the parent, the child is going to do that too. However, I made a change just to show that it is a child. It's going to do everything the parent does, and also whatever it wants to do as well. So it's going to destroy itself. It's going to destroy actor after it spawned the after it spawned the smoke particles, after it spawned the smoke actor. Um, and I think yeah, that's all the principles of OOP. I'm going to explain a little bit more about the ornament and how its vectors work. So if I open a project, actually, you can see the ornament actor just doing its own thing, acting on its own, moving to the right from where I'm standing, moving to the right over time. It's just going to keep moving to the right. But if I hit the actor, it's going to always move towards. It's going to move towards me, and once it hits me, it's going to play ow, right? So, um, it does that because the first thing it checks is this boolean called player touched, and based off of the name, you can probably guess that it's checking to see if the player has touched this object. If the player has not touched the object, it's simply just going to move down in the x vector um, every tick. But if it has been touched, then first it's going to trigger. It's going to turn that boolean to if the player hits it, it's going to set that boolean to true, and then every time it gets hit from, and also every time it gets hit, it's going to play the owl string. But it's also going to start running this code, which is going to set its new location based off of this. Now it's going to get the actor's location, and it's going to It's going to subtract. It's going to use that to subtract from the player pawn location. So the player pawn location minus the actor's location normalized so that it's not too heavy on the computer and it doesn't cause too much lag and it's not trying to gather too much information. That normalized multiplied by the speed, as I mentioned earlier, and I'll explain this in a second, but speed multiplied by the normalized value is then going to get added to the current actor's location, the current ornament actor's location, to set the new location. And once that's done, that's basically just going to be updating um, every event tick. Um, so after the player has hit the ornament, from then on it's going to constantly move towards the player's location based off of the speed of the ornament. And the ornament speed is multiplied by delta seconds. This is so that instead of going by every frame tick, we're just going based off of time. So this is done essentially so that whenever the computer is running slower, I mean, if the computer, regardless of how fast the computer is running, the units traveled is going to remain the same. So it's always going to be traveling, let's say, 300 units, 300 units per second, right? Something like that. For example, if I didn't have this code, if I didn't have this and I just did like speed goes to this, then what would be happening here is it would be going off of the frame draw. So if my frames are lower because my computer's running slow, it would, let's say, after 5 seconds, it'll only have traveled uh, like 1,200 units or 1,200 units. However, if my computer was running faster, it could have traveled like 1,700 units or something like that, right? Like the whole point of not going off a frame draw is so that regardless of the frames per second, the amount of units traveled is going to be consistent every time. And I think that covers my vectors. So moving on from that, I'm going to move on to my player booleans. I didn't really talk too much about how those work. So so after you've done an input to move, the moving boolean is going to check, is it not true. So is moving boolean not true, and is jumping boolean not true, and is moving on the ground true. If that's true, if this is true, and if this is true, then it's going to go to this branch and it's going to check to see if this is true. If it's true, then it's going to set this boolean to true, and it's going to set moving to true, and it's going to create this sound and play it, the footstep sound. Now, if I don't know what I did there, but if I pull up the project, you can see here, moving boolean is set to true, so it's going to play the sound. Now, if I go back to my code, whenever the player completes this action, so whenever they stop moving in a direction, so arrow keys are WASD, or whenever the player does the jumping action, the sound is going to stop playing. So if I close this, jump stops playing, and if I stop moving, stops playing. Now, what also happens here is I set the moving boolean to false, so then this event can possibly be triggered again. This can, because if I never set this to true, then this could never work. This would never be true. This would never be true. So what happens when I jump is basically it checks to see if the jumping boolean is not true. If it is not true, then it's going to set it to true. And if it is true, then we're just going to go ahead and move along to the jump. And then after that's executed, it's going to execute setting the jump boolean um, to false. So what's essentially happening here is going to set the jumping boolean to false right here. There we go. And because of that, anytime you jump, regardless if you're moving or not, it's not going to play the sound. And even if you jump and then you start moving, it's not going to play the sound until you're on the ground, because it's checking to see if the jump condition, if you're moving on the ground, to play the sound in the first place, and it's also going to check if the jump boolean is false or not. Um, and I also two more things. I added a key pressed for Q. So when you press the Q button, it's going to teleport you. It's going to run this teleport code that I have right over here. It just gets the it's going to get the large moving column that you saw near the top of the statue. It's going to get its location, and then it's going to get its vector, and it's going to, oh well, after it's getting gone its vector, it's going to add 700 to the z vector, and it's going to set the player location to that position. That's what the TP does. But um, also, when you release the key, it's going to be checking something. It's going to check to see if the input shift, left shift, is down. And if that's the case, then I'm going to set the Boolean shifting to true, and then I'm going to print the string shifting. And I don't really need this. Just going to print shifting. But if I press play here, you can see this in action. So if I press Q, even when I release it, it doesn't do anything. But only when I press it, it does something. However, if I hold shift and I press Q, it's not going to do anything. But if I release Q and I'm still holding down shift, it's going to press shifting. And if I press Q and then I hold shift and then I let go, it's going to press shifting. All that matters is I'm holding shifting when I release the key, because it's going to be only checking to see if I'm holding down the key when this action has occurred, not this one. Which is helpful, for example, if you're trying to do like a charge attack. So when released, press can be used to check to tell the code that you're doing an attack, and then is input down could maybe even tell the code what attack to do, for example, um, or just tell the code like to do another input in conjunction, um, because I mean do another input because you're holding down shift while you're doing the released key action. Um, And last but not least, I also have a few sounds that I implemented. I think I briefly mentioned this earlier, but maybe I didn't. My footstep sound effect, as you already heard and saw, and then my celebration sound effect, which is in this trigger box. Now, the trigger box, when the player overlaps with it, it's going to destroy the actor and it's going to play the celebration sound, and then it's going to spawn the coin hoop. After the coin hoop has spawned, it's going to get the player's transform, and it's going to return that value, and it's going to spawn the coin hoop at that location. Now, spawning the coin hoop at that location, as you already remember, as you might remember, is going to spawn the smoke effect. So if I press Q, and then I jump to the top, the trigger box gets destroyed. It plays the celebration sound effect, and it's going to create the coin hoop. Since I touch the coin hoop, it's going to spawn um, that smoke effect. So, that's about everything in my project. I think I touched everything that the rubric asks for, and yeah, I think that's it.